So in yesterday's class, we talked about exponents. We learned about all the basic rules of exponents. Hey Vasundhara. Hello sir. Hi Samhita. Okay. So in yesterday's class, some of you were not there. I think Aryahi was not there, right? Aryahi? Yeah, okay. Aryahi was not there, and I think Gitesh, you were there, right? Yesterday? Or no, that's what I was struggling to recall if I saw you with me in the class yesterday or not. Okay. So in yesterday's class, we basically, see, this is better. So all of you who are not having any fear of camera, I would suggest keep your video on. That makes it easy to interact with you guys. And when I explain something, by looking at your face, I can make out whether I have got you more confused or I was able to explain the concepts better. Okay. So that's the main purpose of keeping your video on. And I would know if I'm able to do a good job as a teacher or not. Alright, so yesterday's class we talked about the basic concepts of exponents or the rules, exponent rules that we talked about, and we learned how those exponent rules are derived, and then we looked at some of the problems, actually one of the problems that was there in the test, and we tried digging through it. Then we looked at what is meant by a negative power to the exponent. Then we also learned how do you decode or understand that any number to the power 0 is 1, except the number being 0 itself. Now with whatever I have said so far, anything that I said that was not clear or that you are not able to recall, be honest, that's okay. I'm here to teach you guys the same concept 20 times, 25 times, 50 times, 70 times, 200 times is also okay. Yes, Laksh. I'm sorry?
What was the second and third concept that you were saying?
So we talked about the exponent rules. Then we talked about how do you interpret a negative power to an exponent. And
I don't recall.
Okay. Were you not there in the class yesterday?
I was.
Oh, you were there, right? It's okay. So I see some faces where with a question mark. So that's why I will make sure that I go through those concepts one more time. And today our plan is to talk about the rational exponents and radical exponents as well. That will be extension of what we already know. So let's go through that. That's quick. Class is already halfway through. Okay. So we have is that Suhina with the name Pooja? Yep. Okay. That's why I should not be asking this question once I see the face. Alright. So we talked about 3 exponent rules. One says x to the power a times x to the power b equals x to the power a plus b. Second exponent rule says x to the power a divided by x to the power b equals x to the power a minus b. And the third exponent rule says x to the power a whole thing in bracket to the power b equals x to the power a times b. These are the 3 exponent rules that we learned yesterday. Now let's decode it. First one says x to the power a into x to the power b equals x to the power a plus b. Now x is a variable. X could be 2, x could be 3, x could be 5, x could be 500, x could be 2 million, x could be 5 trillion also. Yeah? Or x could be 0 also. Let's see. Here, Advik. So Advik and Gayatri and Sanvita, some of the kids who joined just now, they seem to have some doubt about the exponent rules that we talked about yesterday. and some of the kids were not in the class, like Gitesh and Aryahi were not in the classes today. So it will be just a recap for you guys and a fresh learning for the kids who were not in the classes today. And Sanvi, Myra, everybody else, please just pay attention to what we are doing so that this becomes rock solid in your minds and doesn't disappear ever. Yeah. So first rule, x to the power a times x to the power b equals to x to the power a plus b. Let's say if I have 2 to the power 2, what does it mean? It means 2 into 2. If I have 3 to the power 4, what does it mean? 3 into 3 into 3 into 3. Correct? Yep. Now we are talking about a situation where I am trying to find out 4 to the power 2 into 4 to the power 3. Meaning this one will translate to 4 into 4. 4 to the power 2 becomes this times 4 to the power 3, that is 4 into 4 into 4, 3 times this one, correct? Now how many 4s you have? 1, 2, 3, 4, 5, which is equal to 4 to the power 5. This is what the first rule says. X to the power a plus into x to the power b equals x to the power a plus b. For x, this is x. This your 4 is your x. X to the power a, here a is 2. X to the power b, here b is 3, equals x to the power, which is 4, a plus b. This is what we saw here just now. Yeah? Make sense? That's Aryahi. And don't be compelled to say yes, okay? If I need to explain it 5 more times, I don't mind. Yeah? I take pride in teaching the same thing 20 times. That's okay. Okay? Sound okay? Yeah, better? Okay. Alright. So this is the first rule. That means tomorrow if somebody says multiply 7 to the power 5 into 7 to the power 7, you will say okay, x to the power a times x to the power b equals x to the power a plus b, 5 plus 7. And we just saw that. So this becomes x to the power 7 plus 5, 12. That's it. Yeah? Yes, Sammy.
Never mind, you just answered the question. I thought you only write like 7 to the power of 5 plus 2, I mean 5 plus 7.
Yeah. No.
Or like, can you directly write 7 to the power of 12?
You can always, if it's that straightforward, you can always do that. But somebody like me, right, from old school, I always recommend or prescribe the kids to do it step by step, so that you don't, if you see this and come to this, you might think what happened in between. If you put this step, that gives you a clear indication that okay, this becomes this one. This relates, this whole thing relates to this first rule of exponents. Yeah?
Yeah.
So when you do step by step, it gives you the opportunity to review your own work, and if you are making a mistake, you'll be able to catch up or recover from that. Yeah?
Yeah, thank you.
Yeah. Okay? So everybody clear, right? No confusion? Aryahi, Laksh, everybody clear? Now let's go to second one. So first rule is okay. Tomorrow if somebody says find out 5 to the power 9 into 5 to the power 17 into 5 to the power 14. 5 to the power 9 is what? 5 into 5 into 5 into 5 into 5 into 5, 9 times. 5 to the power 17 is 5 into 5 into 5, 17 times. 5 to the power 14 is 5 into 5 into 5, 14 times. You don't have to do it in a dirty way. You have a smart way now. You know that when you are adding powers, multiplying powers, the power gets added. Multiplying exponents with the same base, the power gets added. Let's say if you don't know how to multiply 3 of them, that's okay. You know 2 any which way, right? X to the power a into x to the power b. This becomes x to the power a plus b, 9 plus 17, 26 into 5 to the power 14. So this one is from these two multiplications. Now you have again same situation. X to the power a, your a is 26 now. X to the power b, your b is 14 now. Same base. You will say its power 26 plus 14 is 40. So what it means is if you have to multiply exponents with the same base, you end up adding all the powers. Make sense? Now let's go to a different problem. Now, if I have 5 to the power 8 divided by 5 to the power 2. Here x to the power a divided by x to the power b. This is your second rule. And I'm not forcing you guys to believe this rule. You can always solve it. And how you will solve? Let's solve it like a baby. 5 to the power 8, that is 5 into 5 into 5 into 5 into 5 into 5 into 5, 7, and one more time, 8 5. Divided by 5 to the power 2, 5 into 5. 1 5 1 5 tic-tac-toe. 1 5 1 5 tic-tac-toe. How many 5s you are left with? 1 2 3 4 5 6. So 5 into 5 into 5, 6 times. That is equal to 5 to the power 6. So what we saw was, when I had something to the power a divided by something to the power b, that is nothing but something to the power a minus b. That is how you got a 6. Yeah? If I say divide 5 to the power 4 by 5 to the power 1, or divide by 5, that is nothing but 5 per 1. Same thing, 5 into 5 4 times, divide by 5, 1 5 1 5 gone, tic-tac-toe. What you are left with? 1 2 3, that is 5 to the power 3, which is also equal to 5 to the power 4 minus 1. This is your second rule of exponent, which says x to the power a divided by x to the power b equals x to the power a minus b. Whatever you have in the numerator, that power minus the denominator power is what gives you the answer for this one. Yeah? Is that okay? This is the second rule of thumb for exponents. Is everybody okay so far? Aradhya, Nehan, Racha, Aryahi, everybody? Yes, Aryahi.
Sorry, sir, I did that by accident.
No worries with that. It's okay. So, but yeah, I'm assuming everybody is clear, right? Now, what does it mean? Yes, Sami.
6 to the power of negative 2.
Mm-hmm. And how do you convert, how do you read this? Like if I say 6 to the power 2, that is 6 into 6. What does 6 to the power minus 2 mean? Yes, Sanvi.
6 to the power of 0 minus 2.
Okay. And what next? Sanvita.
1/6 to the power of 2.
1 over 6 to the power 2. That's
How 6 times is how 6 to the power of 2, 6 times 6, maybe 6 to the negative power of 2, 6 divided by 6.
no. So that is, see here, if I have 6 to the power minus 2, can I write this as 6 to the power 0 minus 2? Yeah? Now look at the second rule. Something to the power a minus b equal to something to the power a divided by something to the power b. That means 6 to the power 0 divided by 6 to the power minus 2, 6 to the power 2. That is how this will become 6 to the power 0 minus 2, correct? Now 6 to the power 0 is how much?
6.
1. Yeah? Over 6 to the power 2. So, hereafter, yes, Arav?
I was going to say the same thing.
Okay. So, hereafter, for the sake of comfort or with respect to navigation with these kind of things, whenever you see a power negative, you will just move it down and change the power from negative to positive or positive to negative. Yeah? If I ever say 1 over 6 power 2 and you don't like fraction, you will say I can also write this as 6 to the power minus 2 because you are making this guy move from here to here. So your power changes from positive to negative. Now let me give you guys a riddle to solve real quick before I move on. Can you guys solve it real quick? Notebook. Make use of the notebook that Daddy has bought for you. Yes, Arav.
So since the 6 by the power of 8.
Do it. No. Don't tell me story. Do it on a piece of paper.
Okay.
Otherwise, the paper will start rotting soon. Everybody make use of the pen and paper always. Because that builds up as your muscle memory. Vasundhara, Moira, Urvi, sorry, everybody trying, right? Nihan, Sanvita, okay. See, I don't doubt anybody, but I'm just making sure that I'm keeping you guys all awake because at times my teaching might get boring. Notebook, do something.
Do you want us to simplify or let the answer?
Give me the answer, then I'll ask you what approach did you take.
Okay.
I'm sorry if I'm being nagging kids, but I don't get convinced if I don't see you guys doing it. Myra, what's happening? Are you doing it?
Yes, sir.
Okay. Arav, Advik, everybody doing it, right? I want you guys to waste your parents' money on pen and paper as much as you can. Yes, Sanvita.
I got 6 to the power of 7 over 1/6.
6 to the power 7 over 1/6. So something like this. Like this.
No, like 6 to the power of 7. And then that's the numerator, and then the denominator is over, yeah.
Like this. Can you simplify this further? I'm a very simple person. I want you to simplify this. See if you can. Advik.
I got 6 to the power of 7 over 6 negative 1.
Okay. Can you simplify this further? See, as I keep on insisting, I am here to make your life simple. You have to give me simple answers. Yes, Anvita.
6 to the power of 8.
Okay. 6 to the power of 8. Yeah. This is one number, okay? I mean, I'm not saying whether this is right or not, but I would lean on that. Yes, Advik.
6 to the power of 8.
Vasundhara.
6 to the power of 8.
Suhina.
6 to the power of 18.
18. Okay. Lach.
6 to the power of 8.
But Aryahi.
6 to the power of 8.
Okay. Anybody who is still working on it? Arav. And whoever has given me answers, by now, you can bring your hands down so that I would know if there's anybody waiting in the queue. Okay. Alright. Now, here's the thing. Tasvik, what's going on? Did you do it? Did you try doing it? No, see, it's not about you knowing it perfectly or not. It's about, did you try? If you don't try, what will happen? Do it. Do it. I'm giving you time. It's okay. I want you to do it because when you do it, I will know where you're getting stuck. Then I'll be able to take you out of the situation. If you don't do it, I would not know what's going on. Okay? That's why you would have seen the doctors take your blood out, and taking blood out is painful. But then that's the only way they can diagnose. Correct? That's the only way they can figure out what's going inside. So I'm not trying to take anybody's blood out. I'm just wanting to see the blood on your, not blood, your solution on the paper so that I would be able to figure out whether you're able to go in the right direction or there's some change that we have to do. Okay? Just do it. I will request everybody's parents to buy 2 extra notebooks for you guys so that you can waste more papers. Okay. Now let me try doing it on your behalf. See, this is multiplying this and then dividing. Let's do the multiplication part first. Division I'll do later. I have 60 here, 6 power 8, 6 power 4, 6 power minus 3, 6 power minus 2. All have same base. That means when I am multiplying, I will add the powers. So it becomes 6 to the power 8 plus 4 and plus of minus 3, that is minus 3 and minus 2. So it became 6 to the power 8 plus 4, 12, minus 3 is 9, minus 2 is 7. So 6 to the power 7. Divide by 6 to the power minus 1. And 5 minutes ago, if you remember, what did I say? If you have negative power like this, you can write this as 1 to the power minus 1 to the power 1 over 6 to the power 2. Or if you have something as negative here, if you go up, that becomes positive. The sign changes. So here, instead of dividing, I will convert this to multiplying. Multiply this, make this guy go up. When this guy goes up, the sign changes from negative to positive or positive to negative. Since I have a negative here, this becomes a positive power. Now, two exponents getting multiplied with the same base, different power. First rule of exponent, 6 to the power 7 plus 1, 8. 6 to the power 8. Does it make sense to everybody? Suhina, Myra, Sarya, Arihai, everybody? Arihan, you are 24 minutes late for the class, but I hope you'll be able to catch up. Sanvita, everybody, are you guys convinced about the approach that I took, or it is sounding a little weird as I always do? No? Lach, okay? So again, this is something like a muscle memory that I always talk about is this. If you ever have something like 8 to the power minus 5 into 4 to the power 6 divided by 8 to the power 2, you don't have to recall all these rules. Simple. Oh, I have minus power. Let me move this guy down so that I have all positive powers. Minus 5 becomes plus 5 when I move from numerator to denominator. That's it. Now you'll apply the rules and solve it, whichever way. So moving this thing, let's say if you have equal to sign, 5 over 8 equals 8, x equals x times 2 over 9. What you know? Okay, when I'm moving these things, it goes like a cross. 5 comes down, 8 goes up. So this is like a muscle memory, right? I don't have to remember a formula for doing this, right? Just by looking at it, I know, okay, if I have to keep x here, move everything to this side, so it moves like this. So 9 goes here, becomes multiplication, 2 comes here like this, and then I'll do all my calculation, Correct? So there are certain things in the math itself that will be like a muscle memory, for which you don't have to memorize the formula. 9 is a 72, it's a muscle memory for me. I have memorized the table so much so that I don't have to think about 9 times 8 is 72. I mean, that was just an example, right? That's why I keep on insisting the kids to memorize tables, because if you memorize tables, your life becomes so very easy and fun when it comes to doing all the multiplications. Okay? 99 is how much? 19 times 9? Yes, Sohina.
172.
171. This is part of muscle memory for me. And again, it did not come to me for free. I have got enough, I'll not say what, when I was small. Okay? So that's how we learn. Arihan is thinking, what did I get when I was small? I will not disclose those secrets. I'm not supposed to. But again, I'm not advocating anything right now. What I'm saying is, everybody has to put the effort. Sometimes we are being playful and we ignore that and we don't learn it. Sometimes somebody pushes us hard to do it and then we learn it, right? I mean, I have not studied because I wanted to study. It was my dad who was after me to force me to study. I'm just kidding. Okay? All right. Let's move on to some serious business. Now, this part is fine. Now we are wanting to talk about something that is called rational exponent. Exponent you saw. You said 3 to the power 2. Understood. Easy. How about 3 to the power? As soon as I said 6 to the power minus 2, we started thinking, right? Then we figured out, okay, this moves down. Now, if I add one more complexity to it and say, okay, 3 to the power 1 by 2, what does it mean? Any idea what this means? Anybody? Yes, Laksh.
Like 3 to power negative 2.
No, I'm saying 3 to the power 1 by 2.
Then I have no clue.
Okay, Sami. Let's see what Sami says.
This might be a really bad guess, but I think you would multiply 3 by 3 and then take away half.
Okay.
3 divided by 3.
3 divided by 3. Now tell me one thing. Do I look a complicated creature? No, right? I'm not a complicated creature. So 3 by 3 will be what?
1.
Why would I write 1 as this? That's a valid question, right? Gayatri, any idea with her? So I asked one question, okay, 3 to the power 1 by 2, what does it mean? How do you interpret this? And I was given one answer as, this is probably 3 by 3. If it is 3 by 3, that results into 1. Why would I waste so much energy, time and to write 1 as this? If 1 over 2 is 1, how about this? Will this be also 4 over 4 and 1? No, right? Yes, Anvita.
Maybe it means like 3.1.5 because 1.5 is half of 3.
Now 3 say that again.
3 times 3.1.5. I mean, never mind. 3 times 1.1. 3 times 1.5. Yeah.
3 times 1.5. 3 times 1.5.
3 divided by 2.
3 divided by 2. Okay, those were all creative answers. I'll decode this for you guys. There's something called square root. Do you guys know what is square root? Square root. Yes, Laksh.
You're asking for square root, right?
Mm-hmm.
Basically, it's basically reverse of square. For example, like 4 square root is 2.
Mm-hmm. Okay. Reverse of square. Any other point of view? I saw one more child had raised his or her hand, which has gone down so quick.
I was about to say the same thing.
Same thing? Okay. So today Nihan can talk. Till yesterday his mic was not working, right? Okay. How about the video? Why don't you turn on your video, beta? I love seeing you all on video. Wonderful. This is better. Okay. So square root is a reverse of a square. If I say this is 2 square. Okay. If I say this is 3 square. If I say this, anything to the power 2 is also called square of that. Yeah? Gayatri, Myra, everybody agrees? Yeah? So anything to the power 2 is called square. Square root is taking you back in history, meaning reverse of that. If 7, this is 7 square, which is 49, 7 into 7. Square root of 49 will give you 7. Meaning, this is square. Square root of that. 7 square is nothing but 49. This is called square root. Square root of 7 square, which is 49, is 7. This is reverse of that. So if I say, let's muddle the water a little bit more. If I say 8 square, that is equal to 8 into 8, that is 64. If I say square root of 64, meaning square root of 64, that is 8 square, 8 into 8, that is 8 square. Square root of 8 square will give me 8. So basically this square and this square root symbol nullifies each other, and then you get just this number. Yep, 100%. Make sure you go to the bathroom and come back quickly. Yeah. So square root is nothing but reverse of a square. If you have a square, let's say if somebody says find out the square root of 9. This symbol is called square root. Square root of 9. So you will say, okay, if I have to find a square root, is it a square? Yes, 9 is 3 into 3, which is nothing but 3 square. So a square root of 3 square will be nothing but 3. So if you look at it carefully, this 2 and this symbol actually cancelled each other and got you 3. If somebody says find out the square root of 49, square root of 49, first thing you will say is, okay, is 49 a square of something? Yes, 7 into 7 gives me 49, which is nothing but 7 square. That is, so square, I have a square and I have a square root. I will kill both of them. I get only 7. Yeah? Is it okay? So, square root is reverse of square. Similarly, cube root is reverse of cube also. What is a cube? Ice cube. Yes. Yes, Sami, Samrita, whoever. Go ahead.
So a cube is like kind of like a square, but like instead of power of 2, you go to the power of 3. Like for
Yes.
example, 3 to the power of 3, or 2 to the power of 3. So 2 cubed is 8.
Okay.
The cube root of 8 would be 2.
Correct. So let's look at the way this is represented. So Sanvita, did your answer was in line with what Sami said, or you had a different point of view?
No, it was the same thing.
It was the same thing. So now let's look at it again. 4 square. This is 4 square. 4 to the power 3 is 4 cube. 7 square, 7 cube. If I just write this thing, I'm talking about square root of whatever I have inside. So if there's nothing here, there's something invisibly written here. That is 2. When you see a 2 here, it says square root. meaning reverse of square. If I want to write a cube root of something like this, I'll put a 3 here, default, tiny 3, okay, right next to this one. If I don't write it, that means square. I'm trying to find out the square root of this number. If I don't write it, default assumption is I'm trying to find out square root. If I put a 3 here, now I'm trying to find out cube root. If I put a 4 here, I'm trying to find the 4th root. Does it make sense? Now, what is this thing called? Whatever it is, let's say let's say I have a square root right now. I've not written anything here, so that is square root. If I am very generous, I want to waste some ink, I will still write 2 here. That is also the same thing, okay? So, this is square root. This is called radical. This is the radical exponent. This is the radical way of representing an exponent. You will tell me why. This is square root. I can write this also as whatever I have here as this exponent. Is your power 2, this is power 1 by 2. 1 by 2 meaning square root. So if you're writing it like this is called the radical exponent. Here you put the exponent in the form of a rational number. So this is called rational exponent. So when you hear the terms radical exponent or rational exponent, don't freak out. Both are the same. These are two different methods of representation. Like we all have one official name and one nickname, right? Or some of you have many nicknames like me, right? So these are different names, but are different ways of representation, but it's the same thing, okay? So you have, when you put it like this fancy bracket, this is called radical exponent. You have some value in the form of exponent, where you are representing this using this radical sign. If you represent the same value in this form, where your exponent is in the form of a rational number is nothing but fractions, right? When your exponent is in the form of rational number, that is called rational exponent. Now you guys will think, life was going so far fine. We learned exponents. We looked at some negative power to the exponents. We learned how any exponent to the power 0 is 1. But all of a sudden, it changed. And we talked about radical and rational exponents. Because whenever you have an exponent, it follows these rules of exponents. Okay? So let's look at it. Let's look at some difficult looking problem which has a very easy solution. Now if I say 1 by 3 to the power 1 by 2 multiplied by 1 by 3 to the power 1 by 2. Can you guys find it out? Time for dance. Is it looking difficult? Right? It's looking difficult, right? Arav is crying. I am dancing. Arav is crying. Everybody has different expressions. Arya, hi, how about you, beta?
I don't know.
You're also crying?
No. Yeah.
Laksh is confused.
Yeah.
So much of mixed expression. Yes, Advik. Let's see what Advik has in store for us.
Is it just we're playing 1/3?
Saurya is also crying. How did you come to that, Advik?
Because like you said, like xa times xb equals x a plus b. So 1/2 plus 1/2 equals just like 1. And so like 1/3 to the power of 1 is just like 1/3.
I would have given you one hug for this answer. Okay? Arav, tell me. Let's see if you also are going to get a hug.
So I think it will be 1/3 to the power 4 because if you apply the multiplication
multiplication rule on, like, let's say 2 to the power 1 times 2 to the power 1, it will be 2 to the power 2.
So how come it will be 1/4?
No, I'm saying it's 1/3 to the power 4 because you can add the exponents if it's multiplying.
Okay, so unfortunately, a teacher with low aptitude, I'll have to do it. I will not be able to follow you guys if I don't do it myself. Okay, coming back to a serious point. Like I said, this is an exponent, this is also an exponent. Okay? And Tasvik, I would request you to get into the habit of wasting your paper as much as you can, okay? Treat your daddy like enemy when it comes to wasting paper. I mean, only for wasting paper, okay? Daddy, there is nothing better than daddy, okay? I'm saying, treat him like your enemy. Then, okay, I'll make him pay for it. Let me waste a lot of pages. Okay? Alright. So, here, this is 1/3. What is 1/3? It's a number for me. I will treat 1/3 as x, like what Advik was saying. This is x to the power something. This is also x to the power something. That means x to the power a into x to the power a, x to the power b, where a and b are same anyways. X to the power a into x to the power b equals x to the power a plus b. So let's say this is my x. It becomes x to the power a plus b. Half plus half. How much? 1. If you are not convinced, let's do it. What is my LCM? 2. 1. 2 1 are 2. 1 into what I have in the numerator 1 plus 2 1 2 1 are 2 and what I have in the numerator 1. So it becomes 1 into 1 is 1 plus 1 into 1 is 1 divided by 2. 2 over 2 is nothing but 1. So x to the power a times x to the power b equals x to the power a plus b. That's why I was saying, Advik, the explanation that you gave me got me convinced. So I was happy about it. And whatever I said, that has no meaning to it, but I was very happy about the way you explained it. Okay? Yeah? Did everybody get it? Now, so tomorrow, if I get really bad and try to scare you guys, saying 1/3, why 1/3 today? 1/6 into 1/6 to the power 1/4 into 1/6 to the power 2/3. Find it out. What I'm trying to say, okay, don't have to find it out. It's simple. This is my x. This is my x to the power 1 into x to the power 1/4 into x to the power 2/3. So when I'm multiplying 3 exponents with the same base, this is my base, this is my x, same. So this becomes x to the power this plus 1/4 plus 2/3. Add these 3 numbers and find it out, done deal. Make sense? Sanvita, Aryahi, Myra, Sami, Suhina, Gayatri, Vasundhara, Laksh, everybody? Okay. Jitesh? Arihan? Yes, Laksh.
I did not accident.
Okay. Are you clear, beta? Okay. Now, one last problem. And that I will try my best to make it look scary, but it is not actually going to be scary. I want you guys to solve it the way you can solve by keeping it as simple. Don't go by the face value. Face has no value, okay? It's only the way you interpret it. Now everybody get geared up for solving one difficult looking problem. I've tried my best to get you guys scared. Let's see. Arav, keep the emotions aside and deal with it. 1 over 3 to the power minus 1 by 2. Let me make it a little easy. Times 1 over 6 to the power 2 divided by 4 over 5 to the power minus 1. And this, just for you guys to be aware, this includes each and every rule of thumb that we have learned with respect to exponent rules. If you are able to solve this problem, you will have zero problem with exponents in your future. I mean, if you are able to solve this problem, meaning if you are able to solve this by applying the concepts, that will give me an assurance that you'll have no problem. Yes, Amrita?
Is the first one 1 over 9?
It's 1 over 9, yes, beta.
Okay.
Shaurya, Urvi, you have been very quiet, beta. Are you able to follow me so far?
Yeah, I'm following.
Okay. Now give this problem a shot and see if we are able to apply all our concepts without any struggle. I'm not trying to get you guys worried about this problem. I'm just trying to see that whatever we have learned, I'll be able to apply that without any problem. Okay? Give it a try. If it bothers, we'll take care of it. Ariai, you also try, beta? Apparently, I have beef with everybody's parents, okay? Because I'm encouraging the kids to waste a lot of paper. So waste as much paper you can. Don't be shy when it comes to wasting paper. Yes, Arav. Sorry, one more time.
About negative 1 over 810.
Negative 1 over
810.
810. So good that you have finished it already. I would suggest use that time to review your answer, okay? Because that's one thing I would want each one of you to practice. Doing it quick is perfectly fine, but use that extra time for review so that you improve your chances of being more accurate. And whoever is a big fan of AI, see how much of nonsense AI is creating when I'm trying to teach basic concepts of math. See, FR. Who asked AI to give those fancy terminologies? Okay, Aryan, solve this for me. We will have more fun with AI later. See? Guys, don't get distracted by this AI nonsense, okay? You get married to AI, okay? Arab when you grow up. I'm just kidding. Okay, AI is fine. I have no concerns with AI as such, but in general, it's an overdose of AI, which is a distraction. So stay away from the distraction is what my message to you all would be. Alright, Myra, are you trying it?
Yes.
Okay. I want everybody to do as much step by step and get stuck. When you get stuck, you let me know. That's what happened. Exercise time.
I'm thinking.
Okay. Everybody turn their videos off. I can only see Laksh and Suhina. What happened to everybody else? Keep your videos on. Yep, this is better. Myra. Sanvita, tell me better.
I got 115.
1/15th. That is 1/15. Yeah?
Yeah.
Okay. Stressful, is it, Serena? Serena is thinking too much about it. Okay. Yeah. Do it. I mean, it's okay. I'm just trying to keep it lighter for you guys. How about Ariyahi? How is things? How is working better? Difficult?
It's not good. It's like I'm trying.
Okay. Yeah.
Almost there.
And my only recommendation to everybody would be think simple. Always think simple, okay? Don't overwhelm yourself by making it look like a big deal. Yes, Arihan.
I got 19,600.
19,600. That is 19
Like
over
19 over.
600.
Yeah. I'm checking if I can simplify it though.
Yes. So whoever has solved it already and given me the answer, use this wait time while your friends are doing it to review your work, okay? Because we don't do it right always. And it's a very good practice to review your own work, okay? This will improve your chances to get better score always. Sanvi has gone very quiet. Are you trying, beta? Yes, Laksh.
I haven't fully simplified it yet, but I got the square root of 1/9 plus 1/6 plus 5/4.
No, say it one more time.
I didn't fully simplify it yet, but I got the square root of 1/9 plus 1/6 plus 5/4.
Like this.
Yep.
Okay. So while we are waiting for everybody else to do it, use that wait time to simplify it or review whatever you have done. So that way you yourself would know if there was an opportunity for making it better. Sanvi, Vasundhara, what's happening? Are you able to proceed or there's a deadlock?
I think it's
I'm
4
still
by
solving
90.
it.
Okay.
4 by 90.
4 by 90. Okay. Give me a notebook. Let me see if I can make some sense out of it. Okay. Yes, Vasundhara.
I got 115.
1/15, like this one?
Yeah.
Okay. Okay. So same way, probably I'll give. Oh, it's almost time. I cannot give a lot of time to kids. So 1 more minute and then I will do it. Yeah, Rehan.
Me change me answer to 1/135.
1/135. Okay. So now it's time for me to do whatever I can do with my limited skill. Yes, Ariyahi.
I got 1/15.
You also got 1/15. Let me not get biased with any of the answer and try solving it myself. Now look at this. 1/9 to the power minus 1/2. The way you have to read, okay, if you have 1/4 to the power 2, what it means is 1 to the power 2 and 4 to the power 2. That is how you will read it. So if I had 1/9 to the power minus 1/2, I will read this as 1 to the power minus 1/2 by 9 to the power minus 1/2. This is how I will read it. Yes, Ariel? Saying something?
I'm sorry, did that by accident.
No worries. Now similarly, if I have 1/6 to the power 2, I will read this as 1 to the power 2 divided by 6 to the power 2. Then divided by 4/5 to the power minus 1, I can read this as 4 to the power minus 1 and 5 to the power minus 1. Yes, Anvita.
For the 1/9 to the power of -1/2, how I did it was I turned it into 9/1 to get rid of the negative. And that was 9. So then I did 9 to the power of 1/2, which is 9 square root, which is 3.
And that was perfectly fine, actually. That approach was fine. I'm just doing that in a very simple way, so that the chances of mistake is less and it's easy for everybody. But your approach was perfectly fine, okay? Now, see, 1 to any power except 0 or even 0 gives you a 1, okay? So that this becomes 1. Now 9 to the power minus 1/2. What we learned is, like what Sanvita said, we can move it above or below or in the opposite direction, and then the sign changes to from negative to positive. So I have negative here, this guy goes up and becomes 9 to the power 1/2 or square root of 9, whatever you call it, into 1/6 to the power 2, 1/6 into 6, divided by, let's keep it divided by 4 to the power minus 1. What will happen here is, this guy will come down and become 4, and this guy will go up and become 5 to the power 1. So minus sign changes by reversing it. Now see, it's getting more simplified. 1 into 9 to the power 2, 1/2, that is square root of 9, into 1/6 into 6, 36, divided by 5/4. So I can convert this to multiplication, it becomes 4/5. Now, square root of 9, meaning square root of 3 into 3 or 3 square into 1/36 into 4/5. This becomes 3 square, square root of 3 square gives you a 3. So 3 into 1/36, I will call it 4 into 9, okay? Into 4/5, because I wanted to do tic-tac-toe, 4 and 4 gone. What I have is 3/9 times 15, 9 times 5, 3/9 times 5. Or I can write this as 3 into 1, and 9 I can write as 3 into 3, and this 5. Tic-tac-toe, 1/5 times 3 is 50, 1/50. Are you surprised that your answer is different, or are you surprised about the way I solved it? Okay. So again, simple thing. Like I said, always try to make it simple or think simple, okay? Because life will bring a lot of complexity to you guys. My only request to you all is don't add anything by yourself. This is 1 over 9 to the power minus 1 by 2. That means 1 to the power this and 9 to the power this. That's why it's put inside the bracket and put this common power. 1 over 6 to the power 2. That means 1 to the power 2 divided by 6 to the power 2. This whole thing to the power minus 1 means this to the power minus 1 divided by this to the power minus 1. See? And when you have a negative power, you can move it from above to below, below to above, and change the sign from positive to negative or negative to positive. So this became 1 to the power minus 1 by 2, which has no meaning to it. It just becomes 1. 9 to the power minus 1 by 2, you can move this guy up, and this becomes 9 to the power minus 1. Instead of minus 1 by 2, it becomes 9 to the power 1 by 2. A square root of 9, that gives you a 3. And you have 1 over 6 into 6. And then again, these things became like this. So once you have this, in this whole calculation, there was no concept of exponents applied. We just used the basic understanding of what a power means and how it moves from positive to negative, negative to positive. That's it. And then we did our basic operations to get to a simplified answer. So as I keep on requesting, one more time, always look at how you would make your problem simpler and then you solve it, okay? When you decode the complex parts and break it down to simpler pieces, you will see that the whole calculation becomes much easier, less overwhelming, more fun. Did I explain that okay? Urvi, Vishundara, Myra, Aryahi, Sani, Suhina, Arav, Adik, everybody? Saurya?
Yes.
What happened, Arav? You're still crying? Crying over spilled milk? I'm just kidding. Okay. Alright. So I will let you guys go. Adik, was it clear or confusing enough? Okay. Gayatri, okay, beta? Okay. Then go have fun. You guys will get 1 week of relief from me. But make sure that you have assignments that will come your way. And again, assignments are not to bother you guys, more to apply these concepts, okay? The problems that I give, those are harder than the problems that you get. But regardless of the toughness of the problem, it is about the concept part of it. Even if this looks scary to begin with, when you decode it, peel off the onions, it becomes much easier. Yeah. So always look at making things easier and then solve it. Alright, bye bye, have fun. Okay? Bye bye, bye bye. Bye bye, bye bye, bye bye, bye bye. Yeah, take care. Bye, Gitesh.